Hello and welcome to our video presentation for PHY210 Mechanics 2 and Thermal Physics. Firstly, for this entrepreneurship-based project, our group has selected the item pen, and we have developed an innovative product called Smartheat pen. This product was designed using an ABC framework, and in this presentation, we will focus on two components. The components is need and approach. So, under the need component, we address a common problem faced by many people. For example, uneven heat distribution and long cooking times when using regular pans. And this issue leads to waste energy, undercooked or burnt food, and user frustration. Furthermore, in the approach component, we propose a solution. For example, our pen is made using multi-layered materials such as aluminum and stainless steel to ensure faster and more even heat conduction. We also apply key principles of thermal physics such as heat conduction, specific heat capacity, and thermal insulation to create a safer, more efficient cooking experience. Last but not least, through this project, we aim to show how physics can be applied in real-life products to solve everyday problems, combining both science and entrepreneurship. So, let's get started.
So after we did some rough observation on the frying pan market, we noticed that most of the frying pan in the market were actually made up from low heat capacity material, and this is not really good because it could cause your food to burn, and in some cases it can cause your frying pan to be in fire, and at the end it will cause your kitchen is in fire in it. And the second problem is we are trying to solve this sticking issue on the frying pan. So I believe most of us ever experience this sticking issue whenever we are cooking a food in it. For example, when we cook an egg, the egg we are cooking always sticking on the surface of the frying pan in it. So it will affect the quality of the food, and this is bad for some companies like hipster restaurant, luxury restaurant, because this kind of business is the quality. So quality is number one. And the third problem is we want to apply the modern technology on the frying pan by adding the warning system on the frying pan so that we can control the temperature of the frying pan. Either we want to increase the temperature or lower the temperature, because the warning system will warn us when the temperature is maximum or minimum. So our target client, the first one is housewives, because housewives have to cook food for their husband, and the second is newbie to the kitchen. The person don't know how to start cook, so they don't know how to adjust the temperature, right? And the last one is the contemporary restaurant, because like I just said earlier, quality is number one.
For component of need for question 3, how often do people experience this problem and when? Well, people experience this problem every day in the kitchen, and this isn't only a kitchen's problem but also rooted in thermal physics. So when heat is applied, the rate of conduction depends on the frying pan's materials' thermal conductivity. However, traditional pans made out of low conductivity materials do not distribute heat evenly. As a result, some areas of the food became thermal hotspots while others remain cooler. This makes the food burnt in one side and undercooked on the other. For example, when cooking steak, the outside area of the steak is burnt while the inside of the steak remains raw. As for question 4, how big is the problem for users of customers, for example, in unwanted costs? In our honest opinion, this problem is very big as it leads to energy waste, which the system, that is the pan and stove, isn't achieving thermal equilibrium effectively. When heat is transferred effectively, the more energy input is required. This affects the cooking quality and results in increasing utility bills. For example, wasted energy. This means higher electricity bills or gas bills. Other than that are wasted ingredients. This increases the cost of groceries. Last but not least are wasted time. This results in lower cooking efficiency.
What will happen if that need is not met? For the first point, food will cook unevenly This means some part of the food will be burned and some still raw. It affects the taste and quality of the food. Second, waste gas and electricity. This increases utility bill because heat is not separated well and need more time to cook the food. The third point, pan easily damaged. When heat is not balanced, some part of the pan get too hot and making the pan damage over time. Lastly, poor heat distribution. This makes cooking hard and slow. The heat does not move properly across the whole surface. What is the unique approach to meeting this need? To solve this problem, we use unique approach based on first, using thermal physics concept. We apply the idea of heat conduction, how heat moves from hot to cold area, to help separate area in the pan. Second, using multi-layer based pan. We choose aluminum and copper because these metals are very good of conducting heat. This will help the whole pan heat up faster and more efficiently. Lastly, bottom of the pan designed with pattern and groove surface. The pattern and groove surface at the bottom help the pan touch the stove better and increase surface contact, so heat can transfer to the pan efficiently.
For the second approach, our solution is to design a smart thermal pan that uses advanced thermal control to cook food more efficiently. This pan includes built-in temperature sensor and heat distribution technology like a layered base with high thermal conductivity materials such as copper or aluminum. This pan can consistent cooking temperature and avoid overheating by adjusting the heat level. By adjusting the heat level, the pan can improve cooking performance, prevent energy waste, and reduce food from burning due to uneven heat. For the third approach, there are two technical issues that we must solve. The first one is heat regulation system. For example, imagine you're trying to simmer soup, but the pan keeps getting too hot and start to boiling. So we need a system that can control the heat, maybe through a button or a phone apps, so it can stay at the right temperature. Second one is material durability. For example, after using the pan many times, it might get damaged if the material can handle the high heat. So we need to use the strong materials like stainless steel that won't bend or wear out easily after heating or cooling many times.
So, the competition of our product, Smartheat pan and other pans out there is most pans on the market today are made from single layer material, which can cause uneven heating, hot spots, and longer cooking times. Some are expensive but still don't solve the problem of efficient heat distribution. So, our Smartheat pan stand out because 1. It uses multi-layer material like aluminum plus stainless steel for faster and even heat conduction. Second, it is more energy efficient, reducing gas or electric use. Third, it has a heat-insulated handle to ensure user safety. 4. It is designed with thermal physics principle, not just for cooking, but for better performance and cost saving in the long run. So finally, compared to traditional pans, our design offers better heat control, faster cooking, and safer handling at all and affordable cost. Thank you. In conclusion, our Smartheat pan is a simple yet effective innovation that addresses a real everyday problem such as uneven heating and energy waste during cooking. By understanding the need of users and applying principle of thermal physics, our group have designed a solution that is practical, efficient, and user-friendly. Through our unique approach, we have proven that physics is not just theory, but it can be used to improve real products that people use every day. So in this presentation, we hope we have shown how science and entrepreneurship can work together to create better solutions for the future.